Alright, so let's start with the single most important thing we need to know about how these AI systems work. When you type something into ChatGPT or Claude, the system you're talking to is at its core a machine that predicts the next word. That's it. That is the entire game. It doesn't think. It doesn't know. It predicts, given everything that's come before, what word is most likely to come next. Now, I know that sounds almost too simple. You are probably thinking, wait, the thing that writes my emails, summarizes legal documents, and debugs my code is just guessing the next word. Yes and no. Let me show you what I mean. Let's say I give the model this sentence. The model doesn't look this up in a database. It doesn't Google it. It just looks at those 6 words, runs them through billions of calculations, and comes back with a probability for every possible next word. Something like this. Then it picks one. Almost always Paris, because that's what the patterns in its training data overwhelmingly suggest. But notice, it's not certain. It's playing the odds really, really well. Okay, but that was an easy one. Any search engine could do that. So let's try something different. Here's the new prompt. Now, there is no single right answer. There are 1,000 ways to rewrite that sentence formally. But the model will still do the exact same thing, predict one word at a time. It might start with dear, then given dear, predict colleague, then a comma, then I, then am, then writing, and so on, one word at a time, until it lands on something like this. Every single word in that response was chosen the same way. Given everything before me, what word fits best here? Repeated dozens of times in a row. This is the key insight. The model doesn't plan the whole sentence in advance. It doesn't think, I'll write a formal email. It just knows from the patterns it's absorbed that after a prompt like rewrite in a formal tone, words like dear and kindly and scheduled are far more likely than words like hey and cool. Pattern after pattern after pattern stacked on top of each other, and the result looks like intelligence. Here's the easiest way to think about it. You already use a version of this every single day, your phone keyboard. When you start typing a message, your phone suggests the next word. That's the next word prediction, a very basic version of it. Now imagine you took that autocomplete and made it 1,000,000 times better. Instead of looking at the last 3 or 4 words, it looks at the last 100,000 words. Instead of a tiny model running on your phone, it's a model with hundreds of billions of tuned parameters running on a warehouse full of specialized chips. Instead of learning from just your text, it learned from a meaningful chunk of all the text on the internet. That's an LLM, it's autocomplete on steroids. The underlying idea is identical. Predict the next word. The difference is scale, and that difference in scale changes everything. So that raises the obvious question, how do you go from predict the next word to a system that can explain quantum physics, write a legal brief, or have a conversation that feels genuinely intelligent? That's what the rest of this series is about. We're going to walk through the entire pipeline, how the model is fed raw text from the internet, how it chews up that text into pieces it can work with, how it's structured on the inside, this thing called a transformer, how it actually learns through a process that is genuinely beautiful in its simplicity, and finally, how you go from a raw text prediction engine to the polished assistant you talk to every day. Each step builds on the last, and by the end, you'll have a clear mental picture of what's actually happening every time you hit send on a prompt. Let's start with where all of this begins, the data.